Okay, today we're going to continue on talking about how to solve word problems using two variables and so on. So let's start first example. Somebody read this for us. Chuck, can you read this for us?
Kenneth has 50 nickels and dimes worth $4.15. How many dimes does he have?
So the question is, how many dimes does he have? How many unknowns though do we have here? Yes, Matthew? One? Actually, there are two.
Oh.
What's one of them?
Dimes and nickels.
Yeah, so number of
Dimes.
dimes and number of nickels, your unknowns, right? Does that make sense? So which letter should we use for number of dimes, do you think? D would be a good choice. What about for number of nickels? N. Go ahead, everybody declare your variables for two of those. And let's see whether we can solve this. Go ahead, everybody declare a variable for two of those unknowns, okay? So how many people did this? Let N equal to number of nickels. Let D be number of dimes. Very good. Let's fill in the chart, okay? Here we go. So we're gonna have value of each coin, number of coins, and total cost. We're used to something like this, right? We've done this before. So what are we gonna talk about first? Let's talk about nickels, and then dimes. Okay. So what can you tell me about value of each nickels? Yes, Chuck?
They're
5. Should I put 0.05 or 5? I think it's best to, yes, I think it's best to with 5 and 10. Because I want to keep it in terms of cent, right? I mean, is it okay to put 0.05 and 0.1? Yeah, but you're going to multiply both sides by 100 anyway. Why not keep it in terms of, right? Because we don't want to deal with decimals and so on. So why not keep it this way? Okay, what about number of coins? How many nickels do we have in this question? N. We don't know. And as you can see, if I put N, the total cost, right? Is going to be 5N. What about number of dimes? D, and then of course 10D. We've done this many times. You should know how to do it. And of course, the last column here, what should we put down? This is your total. So what is the value of each coin for total? You can't really put anything there, can you? So you don't put anything. Okay, what about for number of coins? We know what to put. Yeah, N plus D, right? Or you could put down 50, sure. So if you want, you could actually put down 50 there and then, come up with an equation that way. Doesn't really matter because we know that N plus D is going to be 50, right? So that's the part that's, again, what about the total cost? I know it's 415, right? 415, but here we're just going to write 5N plus 10D. Is that okay? So there you go. As you can see, this table is going to help us come up with the equation. Okay, so go ahead and write down the two equations that you get from this table. It should be pretty straightforward. Go ahead, write it down. All right, so who could give me the two equations that we get from this? How about Chuck? Give me one of them.
N plus D equals 50.
Good. How about Chris? Give me the other one. So we got N plus D equal to 50. What's the other one?
N equals 5N equals 450.
Good. Should we write 415 or 4.15? 415 because we're doing everything in terms of? Not whole number. We're doing in terms of cent, right? So we're, right, 4.15, right? That's like $4.15. You got to convert that into cent, right? That's 415 cents. So there you go. Which method do you think is best to solve this system? Addition method would be nice, right? So I can multiply the first equation by what? Negative 5 to get rid of the n. Or I could multiply the first one by negative 10. Or, yes, very good. Or I should divide, always simplify. If you notice that the whole equation, the second one, you could divide both sides by 5. 415, 5 goes in, right? So you could do that. Go ahead, everybody go ahead and solve. Let's see what you get. Okay, I'll wait. So I multiply the first equation by 5. Is that okay?
Yeah.
Then, do you have to do it that way?
Nope.
Could you multiply by 10, negative 10? Yeah. Or some of you said, could I use a substitution method if I wanted to? Yeah, it doesn't matter. So no matter how you do it, you get D equals to 33. Is that right? And how many people got D equals 33? Raise your hand. Very good. So look at the question. It asks how many dimes. So we're done, right? He has how many dimes? 33. What if they ask for how many nickels also? Yeah, you plug it in. Which equation is easier?
Substitution. Oh.
N plus D.
Yeah, N plus D equals 50. So if you did that, you will find that, so you plug in D for 33, you know that N equals 17, right? So if they ask for both, that's what you should have written. But on this one, they only ask for a number of dimes, right? So is it okay to just write, Kenneth has 33 dimes? Is that okay? Yeah. Okay, easy enough? Okay, good. All right, let's move on to the next one. Number 2, Carolyn, can you read this for us?
A grocery
butcher prepares a mixture of 30 lb of dried fruit to sell for $4.10 per pound. For the mixture, he uses two types of dried fruit, one selling at $4.30 per pound and the other at $3.90 per pound. How much of each type should he use for the mixture?
That's right. So, Tajwar, how many unknowns do we have? Thank you for reading.
2.
That's right. What are these two unknowns, Tajwar?
How much there is of each type?
Yeah. How much in terms of what?
Um,
How many what?
pounds.
Pounds, exactly. So there are two types of dried fruits that we're going to mix, right? So there's type 1 and type 2, correct? So we want to know how many how many pounds of type 1 we need, and then how many pounds of type 2 we need, right? So that when you mix it together, right, we want to cost something in between 430 and 390, which is 410. Is that right? Okay. So go ahead and declare your variable for two of these unknowns, type 1 and how many pounds of type 1 we need and how many pounds of type 2 we need. Go ahead, everybody do that. Okay, I'll wait. Aaron, what did you do for these two unknowns? How did you declare your variables? Yeah, so let x to be? Yeah, and in terms of pounds, right? So I will let x to be amount of type 1 in pounds, right? Then let y be? Yeah, so we mean type 2, right? How many pounds of the second type of dry fruit we need. Is that okay? So now let's fill in the chart. Okay, here. So we got the amount in pounds. Sometimes it's good to kind of write down like what these units represent. The price is really price per pound, right? Each pound, how much it costs, and you got the total cost. So here's type 1. What should we put for amount? For type 1, how about Sammy? For type 1, how much? X, exactly. And the price is what?
4.3.
Yeah, 4.3 per pound, right? And of course, total cost just from type 1, you multiply them together. 4.3x. In this time, I think this time it's better to use in terms of dollar, right? 4.3, so on. Okay, next, because the amount is kind of big, you don't want to do them in cents, you know what I mean? Okay, type 2, what is the amount for type 2? Samuel? Amount is 3.9? The amount is y, because that's what we don't know. And then the price is 3.9, you're right. And then, of course, total cost, you multiply them together. And of course, at the end, we have the mixture, okay? How much of the mixture? So this one's a little bit different. Last time we did it in terms of the table and so forth. But they tell us what the mixture, right? The total mixture is. What is the total amount of mixture? Yes, Michael? 30. So you put 30. Is that okay? Now, what is the price for this mixture that we want this 30 pounds to be?
Oh,
Yeah.
410.
Yeah, 410, right? $4.10. I just wrote 4.1. Is that okay? And of course, the total cost of the mixture only is going to be? Yeah, Chris. Yeah, 123. When you multiply 30 times 4.1, it's 123. Isn't that right? So in this case, it's best to write this mixture as by itself like this. Last time we wrote x plus y and so on. But this is kind of nice this way because once you do it this way, it is easier to come up with the equations. How many equations do we need since we have two variables? We need two equations, right? So go ahead and come up with two equations. Looking at this table. Again, this table at the end, the mixture is kind of nice to write it this way. You'll see why when you come up with the equation. Go ahead, everybody try. I'll wait. How about Jenny? Can you give me one of the equations that we get from this? Sure. X plus y equals to 30. That's a pretty good one. That's pretty straightforward. So we know that when you add the amount of the dry fruit type 1 plus type 2, it should equal to 30. What's another equation that we need here? Okay, Bella?
4.3x plus 3.9y plus 123.
Yeah, and how did you get 123? Yeah, 30 times 4.1, right? $4.10. Is that okay, guys? So you get two equations. Of course, when you add the amount of the mixture, it should equal to 30 pounds. And of course, the price, right, should be $123, right? The mixture. How do I know it's $123? Because you have 30 pounds of something that costs $4.10 per pound, right? I should put 0 here, just make it. Okay. Does that make sense? Okay, so you got negative. That means something went wrong. So, by the way, do you think, guys, look what I did? Do you think it's a good idea to get rid of all this decimal from the second equation by multiplying both sides by 10? I think it's a really good idea. So, because then it just becomes 43x plus 39y equals to 1,230, right? Yes?
Yeah.
Which method do you think it's nice to use? You could use substitution, sure. Or I can multiply the first equation by negative 39 or so, and then get rid of all the y's. Go ahead, everybody go ahead and solve. You shouldn't get negative, because if you get negative, something went wrong. Go ahead and everybody solve. I'll wait. Okay. Everybody help each other out. Ask your teammates. Okay, go ahead, everybody do it. Alright, so to solve this system, what's the easiest way? I will multiply the bottom one by negative 39. Okay? So when you do, you get, what do we get on the left side? How about Paige? Oh, she's absent. How about Claire? So when I multiply 39 on the bottom one, I get, the first one stays the same. The bottom one I get.
The bottom one.
Yeah, I'm trying to multiply the bottom one by negative 39, right?
Oh, right. Okay, so then you get like 30. Can you get negative 39x
Right? Plus?
plus y? I mean plus 39y plus negative 39.
Good. Plus negative 39y, and then
And then
it becomes 100. Yeah, 1170 negative. When you multiply 30 times negative 39. Okay? Of course, when you add them together, the y's cancel out. What do we get out for the x's? Angel? You get 4x. And then, of course, when you subtract, you get 60. How many people got 15 as the x? Very good. So it means that type 1, dry fruit, we need how many pounds? 15. What about the other type? It's 15 again, because remember when you add them together, it should equal to 30, right? So you can plug in for x. For 15, you get 30. So we need 15 pounds of each, type 1 and type 2. Easy enough? Okay? Very good. Can you do something like this for your homework? Good. Now, on your homework, they're going to give you these mixture problems. Do you guys remember from last time when we did mixture? They also did mixtures of chemicals, right? Like acid and water. Okay, your favorite? Now, okay, good. So one thing you got to remember, listen. When they say, listen up, when they say acid solution by itself without saying any percentage, how many percent of acid are we talking about? Very good, 100%. So you got to remember those. Also, if they say they're adding water to this solution, how much of an acid does the water have? 0. You guys remember that? Also, they're going to have work rate problems. You guys remember work rate problems? So the easiest part is, listen, guys, I'm trying to help you for your homework tonight. Listen up. So if they ask you to figure out this work rate problem, the part that people mess up the most is figuring out the work rate. So if the person works by himself for 3 hours and does the whole job by himself, okay, what's the work rate? 1 over 3. You guys remember is how much work done over how long it takes him to finish? You guys remember that? If the person does his work in 5 days, the whole thing he does himself in 5 days, he does 100% his work in 5 days, what's the work rate? 1 over 5, right? Does that make sense? You guys remember this? So you guys have to remember those to do your homework tonight. Is that okay? But you're going to use 2 variables. It's going to make these things a little bit easier. Okay? And of course, you solve using either addition method, substitution method, and so on. Okay? Can you do something like this then for your homework? Very good. Very good.